Okay, now we're on to our third type of hydrocarbon. This is the third and final type of hydrocarbon. These are the alkynes. So now we're going to something with a Y. So these guys, yeah. So the alkynes are ones that finish in, hang on, let's get the pen working. Excellent. They finish in YNE. They are another homologous series, which means every time you add one carbon, you add the number of hydrogens according to its general formula. These are definitely unsaturated because they are not all single bonds, and they actually are super special because they have a triple bond. This one's formula is CnH2n minus N. So, like before, we have ethyne, propyne, butyne, pentyne, hexyne, heptyne, octyne, nonine, and decyne. They're a bit easier to say than the enes sometimes, but here is an example of ethyne. So eth means 2 carbons, so we follow our formula C2H2n minus 2, so that's 2 times 2 minus 2 equals 2. If you can work through all of that, then you're doing well. So we draw down our carbons, carbon 1, carbon 2. There has to be a double bond. There's only one spot for it. It goes smack bang in the middle. And then we fill up the bonds at the side. Each one of these carbons has 1, 2, 3, 4. Yep, this carbon has 1, 2, 3, 4. Fabulous. We're all happy. Our semi-structural formula is going to be CH. Let's have a look at propyne. So propyne, we have, oh, that's not propene, it's propyne. Does that the same on the other one? No, this other one was fine. So propyne, that means 3, so we go C3H, 2 times 3, which is 6, minus 2, so 6 minus 2 equals 4. Okay, so that's our total formula. Now we're going to draw them out. So we draw out our carbons, 1, 2, 3 carbons. We're going to put our triple bond between the first 2 carbons, then a single bond between the next ones, and then we go and fill in our lines. So this one has 1, 2, 3, 4. Okay, this one has 1, 2, 3, 4. The third carbon has 1, 2, 3, 4. We're all happy. Fill in our hydrogens, and with the semi-structural formula, we end up with CH, C, CH3. Okay, there are some structural isomers of these ones as well. And these, you need to draw some structural isomers of butyne, but these ones are of pentyne. I might just go through one more example with you just to give you a hand. I'm just going to draw out hexyne. I'm going to draw out hex 1-ine. Yeah, so remember how the 1 tells us where the bond is. So hex means 6. So 1, 2, 3, 4, 5. I'm going to put one over here because I ran out of space. 6. The 1 tells me off the first carbon, I have the triple bond, single bonds for the rest, and then I just count out my lines. So that one only needs 1, that one needs none. Up, down, up, down, up, down. All my H's. Yeah, so this one is going to be C6H10 because we've got 2 times 6 is 12, minus 2 equals 10. Let's just check. So if you go through there, you can see that you've got 1, 2, 3, 4, 5, 6 carbons. Good. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Nice. Last thing, let's do it semi-structural. So we've got CH followed by C followed by CH2. Now, we can cheat a little bit here. I'm going to go, how many CH2s have I got? I have 3 of them. Yeah, and that's kind of showing them in the way. And then I'm going to go CH3. And so that's a way of doing hex 1-ine. So there are a few pictures of some structural isomers of pentyne. You need to try and do some structural isomers of butyne. And that is the end of this video.